in this particular class, we are trying to understand the notches which are there in the audiogram. We all know there are two fundamental notches which are very visible in the audiogram. The first is known as the Carhart's notch, which is at 2 kilohertz on the bone conduction threshold. This is found in people having autosclerosis. Why does a notch happen in the 2 kilohertz? So if you try seeing here, the BC thresholds which we obtain are not just, if you start thinking that you put a bone conduction vibrator here and this bone conduction vibrator sends a sound, it goes to the cochlea and the response happens. It is not that simple. There are minimum 4 factors affecting the bone conduction thresholds. Which are the 4 factors? Factor number 1, inertia of the cochlear fluids. That means the fluids which are there, it may be the endolymph or the perilymph. These fluids, what is the density, how they are, the inertia of the fluids matters naturally, because this sound is going to vibrate the fluids and there is a traveling wave which has to happen on the basilar membrane. So the fluid inertia is important, number 1. Number 2, inertia of the middle ear bones. Now from where middle ear is coming in BC threshold, because BC threshold is giving the inner ear thing. No, but when there is a vibration which is put in by the bone conduction vibrator, then the 8 bones of the skulls, they vibrate in different phases, correct? In turn, they create out a sound. The middle ear is filled with what? Air? Air. So it's an empty space, and this empty space will resonate for any sound which is coming. These are bone, no? This resonance happens in 1 to 3 kilohertz range. 1 to 3 kilohertz range. And these resonance, naturally the middle ear bones, malleus, incus and stapes, these 3 also vibrate with it. And they transmit this 1 to 3 kilohertz sound into the cochlea. So the resonant frequency of the middle ear gets transmitted into the cochlea. That's a normal phenomenon. So your BC threshold depends upon the inertia of the middle ear bones. The third point is sounds coming out of the external ear, which means that whenever there is a resonance which is happening in the middle ear or the external ear, the sounds, where it will go? Half it will go this side, some will come out also. So when it comes out, then this theory is known as middle ear outflow theory. So that's why I told you, no, you do ah and then close your ear as you say ah, the quality changes. The quality changes because the sounds coming out are again pushed in. And when there is a conductive loss, as you all know, there will be pseudo increase in the BC, because the sounds are again pushed back and there is a higher sound pressure level which is pushed into the cochlea. So the third factor which decides your BC threshold is sounds coming out of the external ear. Correct? Middle ear outflow theory. And the fourth factor is the CSF, cerebrospinal fluid, and its pressure inside. The cerebrospinal fluid is also important because you have seen in Meniere's disease there will be a low frequency hearing loss because of endolymphatic hydrop. That means if the CSF is more, it fills in, and the low frequency, this cochlear duct becomes tight and turgid. The waves which are there for the low frequency, they get nullified. So there is a low frequency hearing loss. So CSF pressure also plays a role. So these are the 4 factors which decide your BC threshold. Out of these factors, when there is autosclerosis, the inertia of the middle ear bones is something which gets affected. The moment you give a sound, there is a resonance which happens in the middle ear. It is in 1 to 3 kilohertz. Now in autosclerosis, this stapes is getting fixed to the optic capsule here, which means that the sound which is getting amplified 1 to 3 kilohertz is not being pushed inside. It is fixed. No, it is fixed. So the plate will not, the stapes will not move like this, and it will not push in the sound. It is fixed now. So this keeps vibrating, but the sound is not going in. So as the sound is not going in, automatically in 1 to 3 kilohertz, there would be a reduction in, or there will be a higher intensity which will come as a notch. So this notch reflects that the inertia of the middle ear, the resonance of the middle ear is affected. That's the reason 2 kilohertz notch in otosclerosis, also known as the Carhart's notch. The second notch which is there is the 4 kilohertz notch, which happens due to noise induced hearing loss, NIHL. Why does it happen in 4 kilohertz only? The answer is that there are two factors. The first factor is usually when there is a sound which comes in, then the sound is amplified by our external ear. The external ear has two parts. The first part is the pinna. This pinna and the external auditory meatus, which is 2.5 to 3 centimeter long, they have their resonant frequencies. The way middle ear have 1 to 3 kilohertz, they have their resonant frequencies at 3 to 5 kilohertz, right? So by 3 to 5 kilohertz, what happens? They increase the sound by 10 to 20 decibels. So as the sound gets increased by 10 to 20 decibels, the sounds which are going inside in the 3 to 4 kilohertz range would be 10 to 20 decibels more as compared to the other sounds. First reason why 4 kilohertz is getting more affected. The second reason is that the part of the cochlea where 4 kilohertz is deciphered is the basal end of cochlea. This basal end of cochlea, because of the turn, because of the mechanical property, is stiff. As it is more stiff, there is a traveling wave which is happening. It causes more torsion in the hair cells. As it causes more torsion in the hair cells, there will be a breakage of the hair cells, which is more in the basal end of cochlea. On top of that, repairing also happens. But we all know the collateral blood supply is less. Hence, the repairing happens less. Correct? So, because of these three reasons, reason number one, resonance of the external ear, that's the pinna and the external auditory meatus. 3 to 6 kilohertz or 5 kilohertz is more, that's why more sound is given 10 to 20 decibel. Second is the stiffness of the mechanical property of the basal end of the cochlea where 4 kilohertz is deciphered, torsion becomes more. The third is poor vascular supply. So these are the three reasons why you have a 4 kilohertz. So 2 kilohertz not, otosclerosis, 4 kilohertz not. That's the reason. Thank you.